Hi everyone, my name is Filippos Kozakos and this is my Lab03 project. This lab consists of two parts. Part one, finding mass of the black hole, and part two, we have to set the initial velocity vector in order for the spaceship to fly near the black hole and come back out without crashing. As you can see here, the fundamental physical principles are Newton's second law, the momentum principle, and Newton's law of universal gravitation. The brief description of the results of this lab was here are the followings: the mass and the initial velocity vector, important equations, Newton's law of universal gravitation, you can see it here, Newton's second law, the momentum principle here, the velocity update formula, the position update formula here, and then we can assume that F net, the magnitude of net equals to F, the magnitude of G, you set them equal, then you just solve for M. This is the part one, the main idea for part one. Then for the reasoning, F net perpendicular posed towards the center of the circular motion is perpendicular to F net parallel and represent change in direction. The F net parallel is perpendicular to F net, the F net parallel is perpendicular to F net perpendicular and represent the motion of the object. And the position of this formula I have used V final since the universal gravitational force is not constant. And then I assume that the magnitude of F net equals the magnitude of G, because the only force acting on the star is the force due to gravity exerted by the black hole. Then possible errors, the calculation of the black hole, the precision of the mass estimate will depend on the quality of the data and the accuracy of the stimulation. And then the speed of light. In a realistic scenario, it's possible for an object with mass to reach the speed of light. Here are my system, the surrounding, black hole as a system on the left, surrounding star. Here is the surroundings, the star. Initial conditions for part one, finding mass, those are given things, good. Initial conditions part two, fly near the black hole, come back out without crashing. I set the time to be 5 hours. I have used the mass of black hole from part one, the planet speed and planet velocity. Then I have found these two values by trying guessing. That's it. And then coding for part one, I have applied Newton's second law, as you can see here. Second law here is everywhere. Finding V, P, F net, which is equal to delta P and delta T, and so on. Clear. Coding part one, calculating the mass of the black hole, you just have to take the things that I found here and then plug them into this equation to find the mass of the black hole. Results of part one, here are my results, the net, the parallel and perpendicular, and this is the stimulation. Coding for part two, you can see I'm using the mass of the black hole that I found from part one here. I'm using the velocity position update formula, and then I'm calculating the net force. You can see here. The results for part two, initial velocity of the spaceship is this one. I found it through trying guessing. Closing distance between spaceship and black hole is this one, which was the result of the stimulation. Now, similarities, use of mathematical equations, both data analysis and model predictions involve the use of mathematical equations. Then the validation of physical laws, both data and model predictions must follow Newton's law of universal gravitation. And differences, we have the uncertainty factor. Uncertainties may occur on data prediction due to measurement errors. On the other hand, model predictions can be precise. Then the source of information, data is collected from real-world observations of measurements, whereas model predictions are generated through computer simulations. Here are possible sources of error. I have used the guess and try method to form initial velocity values. Different initial velocity can lead to different incorrect result. We'll have set the time interval to be way too short, which this will not give me accurate results. What if when we want to the spaceship to enter in an orbit around the black hole? I have tried several values, but unfortunately I couldn't get a singular motion for it. It is represented by magenta, this color here. This is my closest output. I try to make as circular as possible, but unfortunately I didn't find the specific values. What does it mean? The net force and the rate of change of momentum are related but also different. The net force is a vector quantity representing the overall force acting on an object. And the rate of change of momentum is a measure of how an object's momentum changes over time due to the applied forces. The conclusion, have used data analysis and modeling to estimate the black hole's mass and determine the spaceship's required initial velocity. This lab experiment has showed the relationship between gravitational forces, net forces, and momentum changes. Thanks for watching.